Hey guys, Mr. Middleton here. Today we're looking at special parallelograms notes. At the end of this video, you should be able to use the properties of special parallelograms to find missing side lengths and angle measures. You should also be able to identify a special parallelogram by giving characteristics. Okay, in the last two lessons, we've talked about the properties of parallelograms, and now we'll look at special parallelograms and the additional properties that go with those. Okay, so for our special parallelograms, we're just talking about not just parallelograms in general, but the rhombus with four sides congruent, parallelogram, the rectangle with four right angles. We can also think of it as four angles congruent. Okay, and the square that has both four congruent sides and four congruent angles, or four right angles. Okay, so let's talk about the rhombus. So here's what we'll do. We will talk about the rhombus, we'll talk about the rectangle, and just like the properties of a parallelogram will transfer to the rhombus, the rectangle, so we don't need to repeat those properties, the properties of a rhombus and a rectangle will transfer to the square. Okay, so when we talk about the properties of a rhombus, remember that we already know that their opposite sides have to be parallel because a rhombus is a parallelogram. We already know that their diagonals have to bisect because a rhombus is a parallelogram. We don't need to repeat that information. We're adding to it. Okay, so the first additional property of a rhombus is that each diagonal of a rhombus, diagonal, bisects two angles of the rhombus. Okay, so the diagonal here, AC, bisects this angle so that we know that angle 1 is congruent to angle 2. Okay, we know that angle 3 is congruent to angle 4. Okay, and I really shouldn't have drawn it that way because even though it does bisect this, we know that in a parallelogram, the opposite sides or the opposite angles are congruent. So angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. Okay. The second additional property of a rhombus is that the diagonals of a rhombus are perpendicular. Believe it or not, that was supposed to be an end. Okay. Perpendicular. Okay, and so we see that AC is perpendicular to BD, creating 90-degree angles all around there. Okay, so yes, this is 90, this is 90, 90, 90 all around. Okay, so the additional properties here deal with the diagonals. In a rhombus, the diagonals bisect the two angles of the rhombus, and the diagonals of a rhombus are perpendicular. Okay, for a rectangle, the diagonals of a rectangle are congruent. Okay, and so let's do a problem off of that. So congruent in this case would mean that FD is congruent to GE, right? So here it says that FEDG is a rectangle. They tell us that FD is 5x minus 3 and GE is 3x plus 9. They want us to find the value of x and to find the value of GE. Well, since we know that this is a rectangle, they told us that, that would tell us, okay, rectangles, diagonals have to be congruent. So I can say that 5x minus 3 should equal 3x plus 9. And solve for x. Subtract 3x from both sides, add 3 to both sides, 2x equals 12, x then is 6. Okay, now solving the rest of that problem because they asked us what GE was, and so I should be able to say 3 times 6 plus 9, GE must be 27. Okay. So looking at the converses. Okay, so instead of splitting this into two different lessons like we did with angles, with parallelograms, we can just look at the converses straight up and say, all right, if one diagonal of a parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus. See, we're using the converse instead of saying if it's a rhombus, then the two angles, then the diagonal bisects two angles of the parallelogram. We're saying the opposite, the converse of it. Okay, and that's what we're doing with these other two as well. If the diagonals of a parallelogram are perpendicular, wow, that it is really throwing me off today. All right. Then the parallelogram is a rhombus. And then finally, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Notice that with the converses, we are given, or we start with a parallelogram. Okay, so it's not just like, hey, if we have congruent diagonals, then it must be a rectangle. No, we're starting with the fact that if it's the diagonals of a parallelogram are congruent. Okay, with certain special characteristics, we conclude that it's one of the special parallelograms. All right. And like I said earlier, we don't need to talk about squares by themselves, because just like we can attribute the properties of a parallelogram onto a rhombus, because a rhombus is a part of the parallelogram, we can attribute the properties of a rhombus onto a square and a rectangle on a square, because a square is just a rhombus and a rectangle. So when we think about the diagonals of a square will have congruent perpendicular diagonals that bisect the two angles in the parallelogram. Okay. All right. See ya.